Alright, silly people, here's this situation. We have this wacky matrix here, M, and we are asked very simply, is it normal and is it diagonalizable? So the condition for normal matrices are that it commutes with its own Hermitian conjugate. So that is the commutator of M dagger with M equals 0 is what we're trying to find. So we need to go ahead and find what M dagger is. It is actually just the transpose of the complex conjugate of it. So it's 1, 1, 1 minus I for the Hermitian conjugate. So let's start setting up the commutator then. M dagger M is going to be M dagger M minus M dagger. So it's going to be 1, 1, 1 minus I, 1, 1, 1 I minus 1, 1, 1 I times 1, 1, 1 minus I. So that first combination of matrices makes 2 here, plus, and then the next element is 1 plus I, right? 1 plus I, and then the next element down is 1 minus I, and then this is 1 minus I squared here. Then moving right along, we've got 2 here again, and then 1 minus I here, and then 1 plus I here, and then 1 minus I squared here. So quickly do subtraction of these two matrices. This element cancels out this one, this element cancels out this one, but then we got these weirdos that are 1 minus I minus 1 minus I, and then 1 plus I minus 1 plus I, 0. Right. So those actually, we have 1's canceling each other out, and 1's canceling each other out, but then we have 2I on the top and minus 2I on the bottom, which is not 0. So this matrix is not normal, for sure. Now we need to figure out if it's diagonalizable. The way to do this is to just find what the eigenvalues are if they are there. So setting up the characteristic equation then, we need to calculate the determinant of 1 minus lambda, 1, 1, I minus lambda. Right. And set that equal to 0. So we got 1 minus lambda times I minus lambda minus 1 equals 0. So we have just expanding the two multiplied terms. I minus lambda minus I lambda plus lambda squared minus 1. And I'll group it like this. We'll have I minus 1 plus lambda times minus I minus 1 plus lambda squared. And we can set up the quadratic formula. So lambda will be I plus 1 plus or minus the square root of I plus 1 squared minus 4 times I minus 1 all over 2, right? So just simplifying the stuff inside of the radical, we have I squared plus 2I plus 1 minus 4I minus 4 in there, and that's all over 2. Continuing to simplify, I plus 1 plus or minus square root. I squared is, of course, minus 1. And then we've got 2i minus 4i, so it's minus 2i. And we've got 1 minus 4, so we got minus 3. And actually, now that I think about it, that should be a plus 4. So we got 1 plus 4, so 5 in there, right? All over 2. And we can simplify one more time to get 4 minus 2i inside the radical. Just doing 5 minus 1. And it's all over 2. And I can't simplify it any further, so the plus or minus solutions should be distinct, and if that is the case, then it is diagonalizable, since the characteristic equation has two distinct solutions. All right.